Hey everyone, in this video we're going to be covering the basics of Python programming inside of Rhino. A couple things that we're going to go through are variable and data types inside of Python, as well as an introduction to Python data structures including conditionals, loops, and functions. These are going to be basic introductions to the principles and how we can start to work with them inside of Rhino. In future videos, we're going to cover loop and recursion using functions through a series of design exercises. We can go ahead and get started working with Python inside of Rhino by opening up our Rhino interface, and then we can just go ahead and go to Tools. And then what we want to go to first, at least for this first series of Python exercises in this introduction video, is the Python script editor. So what we want to do is go to Tools, Python script, and then we want to select Edit. This should open up our Python script editor, and we should see a blank file here. So this is going to be our primary interface, at least again getting started inside of Python, for Python inside of Rhino. So this is kind of like a mini command prompt that's going to run our code inside of the Rhino interface. When we first open up this editor, we'll notice that we have a series of menus at the top, including File, where we can save, open, or create a new file. We then have Edit, which are just options for finding, copy and pasting, and selection options. We then have Debugging, which is actually going to give us a fine-tuned control over which pieces of the code we can choose to run. And then we have Tools and Help options. So Rhino does have an incredible set of forums, which are actually included in these YouTube link descriptions. And not just forums, but also help document pages. So if you ever get stuck, whether it's with the Rhino interface itself or Python inside of Rhino or Grasshopper for Rhino, all of these have an incredible amount of resources available to you online. So if we were to click on this Rhino Python fundamentals, we would see a browser page with all of the information that we could ever need to know about Rhino Python and programming inside of Rhino. On the left side tab here, if we expand that, then we can also see we have a Python dropdown. So if I click on this, these are going to be all of our native Python commands. And then if I click on the dropdown for Rhino script syntax, we have listed here each of our geometry types or object properties available to us inside of Rhino. So let's try and find a familiar one, like let's say curve. If I click on this curve dropdown, we can see all of the functions or commands that we can use inside of what's called Rhino script syntax, which is going to be the way that we call certain Rhino functions or Rhino operations inside of our Python script editor. So if we ever need to find something, we can just navigate through this list on the left here. And then additionally, we have a menu for script context. So what script context is versus Rhino script syntax, Rhino script syntax is going to deal more with kind of geometry operations, whereas script context is going to deal with kind of document-based operations. Now that's oversimplifying, but I think that's a good way to start understanding those. And then we have Rhino here. So Rhino is going to be the Rhino Common Library. This is a C-based library, so not written specifically for Python, but we can call these functions even inside of Python. One thing to note is we won't be using the Rhino Common Library to start out in Rhino. Instead, we'll be using the Rhino script syntax, but the Rhino Common Library is quite a bit faster as it's a less interpreted language than Python. So what that means is that Python is a little bit closer to human language and easier to use or more intuitive than C. However, C or C# or even Java are going to be able to run tasks asynchronously and synchronously, and being less interpreted than the Python programming language, they run quicker for the computer because they're closer to computer language. So there's less need or less time required to make that translation. So we're going to mainly focus on some of these built-in Python functions, as well as some of these Rhino script syntax ones. In this introductory video, I'm going to build out a file here that we can use to refer back to understand some of the basic data types and structures inside of Python. The first thing that's important to note inside of Python is that our computer reads code from top to bottom, and there are certain ways that we can structure this code in order to perform operations in particular order. Again, by default, it goes from top to bottom. There are also ways that we can remove certain elements from being read by our computer, and these are what are called comments. So comments allow us to write certain elements inside of our code that are not read as code itself to the computer, but instead are just noted for ourselves to be able to better understand what we're writing in the code. These comments can be identified with a hashtag in front of them. If I put that hashtag or pound sign followed by a space, or we could just write it right up against it, but I'm going to just add a space for visual clarity. And I'm going to go ahead and write, "This is a comment." Now, in order to run a Python function, what we need to do is click on the Start Debugging option at the top. So if I click Start Debugging, we see that the window goes away, it runs our code, but nothing happens. Now, nothing is happening because this is a comment, it's just a comment, so it's actually not running any code. That's not sending a command to Python. So nothing is being run, that's just information for us to read. Another way of writing a comment is by placing 3 quotation marks, and this is what's called a multi-line comment. So with this multi-line comment, we could just say, "This is a multi-line comment," and if we click play, we should get an error here because these multi-line comments require both a triple quote at the beginning and at the end. So if we add this at the end and hit play again, we no longer get that error message in our output console. Any error messages that appear will appear at the bottom window here in our Python script editor. Now, why this is significant is that a multi-line comment allows us to start wherever our triple quotes are started, and then we can place information on any of the subsequent lines before we have our end triple quotes. So these are kind of bracketing or creating a kind of, range or zone inside of our code that is not meant to be read by Python or by our computer, and it's not actually code to, run some function inside of the script editor. Instead, it's just information for ourselves. So not only can we space it out here underneath that triple quote, but we can hit enter and place the triple quotes entirely on different lines. We just need to ensure that we have one triple quote to start and one triple quote to end. Now we can say, "This is a multi-line comment," and hit play, and we still don't get an error message. In fact, we could say, "This is a multi-line comment, period," hit play, and it still operates just the same. So I'm going to just hit enter to separate those out slightly. And what we're going to go ahead and do to get started is give ourselves a comment saying, "The author of this script is," and then we can put our names here. So Patrick. Again, just to check, we can hit that green play button and make sure that there are no error messages appearing. Now, if we wanted to say this in multiple lines, that's where we would use this triple quote. So if instead of "the author of this script is Patrick," I wanted to, all in one line, I wanted to say triple quote, "The author of this script is," and then a separate line. If you saw that, it tried to reference that colon and add a tab. Now this is going to be something we'll come back to later on, but just delete that for now because we want all of these to be in line all the way justified to the left inside of our Python script editor. So now we can type Patrick, enter, and then 3 quotations at the end. Again, not being read inside of our Python script editor or not actually performing a function, just visible to us, the author. Now that we've written that header to this script, which usually would contain information about the date that we wrote the script or possibly what the script does. So maybe we could also state here inside of this multi-line comment, we can hit enter twice and say introduction to Python data types and data structures, all contained within that multi-line comment. So to get started, I want to give us comments to rough out a kind of outline of what we're going to cover in this video. So first we'll go through a couple of data types, which are going to be stored in what's called variables. Now variables can be thought of as containers of information or data that we can name and refer to access the data they contain. So they are like boxes or packages which contain information inside of them, which is useful later on using operations inside of Python. Additionally, we're going to cover something called conditionals. So that's conditionals. And what conditionals are if else statements, or kind of if-then statements, you could think of it like, but the syntax is going to be if-else statements, which work with Boolean values or statements of equality. Now what I mean here is that these are going to be filters to only run certain portions of the code during certain times or under certain conditions. So this is why it's called conditionals, because we only want to run what's inside of the conditional statement under a certain condition. So they're kind of like gates or filters for certain operations inside of our code. The next thing we're going to cover is what's called loops. And loops allow us to allow for iteration of an operation multiple times. Lastly, we're going to cover functions. And functions are packaged set of operations that we can name and then call later on in our script to perform that same block of code without having to rewrite it every single time we want to call it. So block of code we name and call whenever we need to perform that operation set. Okay, if we want to expand this just so that we can see all of those lines, we can go ahead and do that as well. So now I'm going to hit enter to space these out a bit, and we'll go ahead and get started in variable. So under variables, the first data type that we're going to look at is going to be called a string. A string is a list of text characters. So we can go ahead and jump into an example to look at what a string variable is. So anytime that you're constructing a variable, you need a name for that variable. Now this name could be anything, but I suggest that it relates to whatever kind of data type or whatever is being stored inside of it. So I'm going to name a variable here by typing text. So this variable is named text. However, it's going to be of type string, but right now we don't need to declare anything about it being a string. We just need a name for it. So we've nicknamed that container text. Now, anytime we want to know what's stored in that container, we need to call it by its name. We need to say, hey, text, give me that information. So currently, there's nothing stored inside of this. So we could call it by its name, but we haven't actually given it anything to store. To give it something to store, we need to declare it equal to something. And when we're talking about strings, we need that declaration to be a declaration that it is equal to some string value. So our text variable equals, and we're going to just open up quotes here, and then close those quotes. And inside of these two quotes, we need to give it our string values, which are just going to be any text value. So I'm going to write here capital HELLO space WORLD with an exclamation point. So those are all text characters, which we are storing inside of this string, inside of the variable called text. Now, if we want to read this information back, as I mentioned, we need to use the variable name text. One way that we can interface with code inside of Python is by sending this information from what's just stored in this data, because right now, if we click play, nothing is going to happen. It actually is running this storing and declaring of this variable. So we are naming the variable text, and we're storing this information, which is string information, hello world, inside of the text variable. But we're not actually seeing anything, and that's just because we're not giving a kind of interface for our human minds to see what's going on inside of the computer. So one of the ways that we can do this is by clicking on the breakpoint, and then we can click play. So by default, that breakpoint is placed wherever my cursor was, so that's line 25 here. And we can see that that's on the same line where that text variable is declared. And now in our console, we can actually see some information about what is running in the background that we weren't seeing before. So we can see that something is happening here in this script, but nothing is actually being output, so that we can see that immediately as we run the script. So we can go ahead and clear this breakpoint and then hit stop. And now what we're going to do is structure this code so that we actually get information out inside of our output console so that we can read what's happening in the code. The way that we're going to do this is with what's called a print statement. So we're going to type print, enter. Any native function inside of Python is going to be visualized with blue text. So we can see that it registers as that print function, and then we hit space. And inside of IronPython, we don't need any other information like parentheses or brackets or anything. We just need that space, and then we can type the name of our variable, so text. Now I can hit play again, and in our console we see it's printing out that string information. So it's not printing the name text, it's actually printing what's stored inside of that variable. So it prints the information contained in the variable. If we put quotations around that name text, it's going to instead print the actual string text. And that's because we're directly just printing text and not referring to the variable that we've called text. So if we remove those quotations and then hit play again, we can see that it's printing our text variable. The next data type that we're going to take a look at is called integers. Now, integers are any whole numbers. Similar to a string, we need to declare a variable with a given name, so we can call this num. And just like the string, we need to make a declaration and then give it some information to store inside of its variable container. So in this case, since an integer is a whole number, we need to give it a whole number to store inside of its container, which we can say is 3. Now if we want to output this information, we can use a print statement and hit play to debug. And we now see that it's not just printing text, but it's printing the data stored in our variable text as well as the data stored in our variable num on 2 separate lines in our output. That's because Python is reading through from the very top, and it's seeing that this is a comment, so it doesn't actually read it. This is a comment, so it doesn't read it. A comment, a comment, a comment, a comment. Then it gets to this line 25, and it says, okay, at line 25, we've declared a variable, but there's no actual output needed. At line 26, we want to actually call that variable, refer to it, get its data, and then print that data as an output to the console. And then if we go down to line 29, we have another comment. On line 31, we've made a new variable of type integer. That integer has a value of 3, and we're going to print that integer. So that's why we're seeing both of these actually printed out here, is because it's just reading from top to bottom, and any action that it's told to perform, it's going to perform, which in this case is just 2 print statements to our console. The next data type is going to be called a float. And a float is just a decimal number. So any number with decimal place precision. Now we can go ahead and construct a variable here called num_f. So f standing for float, but we could call this whatever we wanted to. So num_f equals, and now we just need to give it some decimal value or number including decimal values to declare it a float. So I can type 3.24, and we can go ahead and print this as well, num_f, and then hit the green button in order to start debugging and run this script. And we can see that printing out again, hello world, 3, and then 3.24. After floats, we have something that should be somewhat familiar to us by now after the Grasshopper introduction videos and the Rhino introduction videos, which are Booleans. Now, we're used to Booleans as volumetric operations, but as I mentioned in previous videos, a Boolean is really a true or false value. So a declaration of true or false. And these are going to be incredibly useful when we get into conditionals, so ways of filtering our code to only run it at particular times. So we can declare a Boolean by, again, naming the variable, and then we can set that equal to either false or true. Now we can write our print statement, and then hit debug, and we see that it prints false. We could also go ahead and change this value, and we could type true instead of false, printing that Boolean again, and now we see true as an output in our console. The last variable type that we're going to take a look at is what's called a list. A list is basically just a data container for multiple variables. So all of these things that we've covered previously, including strings, integers, floats, and Booleans, a list is just going to contain multiple of those. So we've actually already seen this in an earlier variable, which is a string. A string is actually just a list of text characters, so it operates already very similarly to a list data structure. So we can say operates like a string, which is a list of characters. So if we make a list variable, what we need to do to construct a list is give it a name. So just like a normal variable, we need a name for it. And then we need to store information inside of this list. To declare it as a list rather than a singular variable, we need to give it brackets. The brackets are going to be the kind of container, so the signal for the container of multiple items inside. So that's going to be the open square bracket and then close square bracket to declare this as a list. Now if we just print list here underneath that list declaration, we can see that it just prints those brackets again. And that's because nothing is actually stored inside of this list. If we wanted to store things inside of it, we just need to place them inside of these brackets, so placing it in this box, and we need to separate them by a comma. If we didn't separate it by a comma, so let's say we just wrote text, text space num space num f space bool, and then hit play, it's giving us an error because we haven't actually separated each one of these elements properly. So it doesn't know how to read these 4 names just thrown into this box. So we need to carefully place each one of these elements in the box. And even though they all have a different variable type, we can still place them all in as long as we're just adding a comma between each of them. And now when we hit play, we see that our list contains 4 elements. The first is a string, hello world. The next is an integer, 3. The next is a float value of 3.2 with several other points of decimal precision. And then we have a Boolean value of true. We can also see that our string here is actually defined not by a double quote, but just by a single quote or apostrophe on either end. That's because we can define a string either with this double quote or single quote. It doesn't actually matter inside of here. We will see later on that sometimes a double quote actually allows us to read across spaces in other Python environments. In Rhino, it's not going to matter, so we can just use those single quotes, hit play, and that's going to look exactly the same as our previous printout. Additionally, instead of storing all of these values inside of this list, as we've done here, what we could do is say list equals, and then again we need to open that bracket, so the left side bracket, and we can give it some text information like a string, and we can say hello and that string. And just like we did in the previous line, we need to separate this information with a comma. The next input we can give is world, again a string defined by the double quotes on either end of it. And then we'll give it one more, which is going to be an exclamation point. And then to close this list out, we can just close that bracket. And we now have 2 variables named the exact same thing. So what Python is going to do is it's going to read through each one of these lines. It's going to get to line 48, open up this variable or create a variable named list. It's going to set that equal to these 4 items. It's then going to go to line 49 and it's going to replace every item. So basically clear that container out, and instead it's going to take a look at what we're storing here, which is these 3 strings, and it's going to override that information, store that into the same named variable list, and now just print that second bit of information. So we're no longer going to use this line basically at all. It's still going to run, but it's going to be overwritten in this line 49, and then we'll print out in line 50. So if I hit play, we see that now printing out hello, world, and then exclamation point. We'll get into this in a moment, but the primary way we interface with lists are through list indices. So this is going to be a way to call not the entire list all at once, but just individual elements of the list. We can do that with the list itself, but since lists operate similarly to strings, we can go ahead and jump back up to our string variables and we can take a look at how these operate in our strings. So the first thing I want to do here is not call this entire string hello world, but I just want to get the capital letter H. So if we want to do this, we still want to use a print statement, print. Well, we know that we're referring to that variable text, some information inside of it, so we're going to need the name text, but we just want the first index. So what we can do here is we can use syntax to reopen the brackets of the list. So I think of it as kind of opening up the box. We're now looking inside the box and we need to give some information as though there's some person inside or thing inside that box asking, okay, I can give you something, but what do I need to give you? So what we give is the position in the list. So we say, I want the first thing in the list. Now think about if we needed to refer to anything or tell someone to get us anything, we would probably say, I want you to go over there and grab me that thing in the lower right-hand corner of the room. So we're giving this information to whoever we're directing. In this case, we're directing our computer. We're directing Python to run this. And we need to say, okay, I want you to go look in the box called text. I've labeled it text. I want you to open that box. So by opening the box, we need to open the brackets. So we've opened the brackets there. And then we need to give information so that they don't just grab whatever they want out of that box. We want to specify a specific thing in the box. So I want you to grab the first thing all the way to the left in that box. To do this, we use what's called an index. So this is going to refer to just one element or one item inside of our list. And we can do these with integer values. So each index is stored as an integer value, and they range from 0 to whatever the length of the list is. So the starting index is going to be 0 as our first item. And if we input our 0 inside of these brackets and hit play, we'll get access to just that first item, so the 0th item in our list, hello world. If I go ahead and hit play there, we can see that we first have a printout of our full text variable. We then have a printout of just the first item, that first character H, in our string hello world. We could do this for every single index, going from 0 to 1, and now we're printing E to 2, we're printing L, and 3 is going to print L as well, 4 is going to print O, 5 is going to print space, 6 is going to print capital W, and so on. Additionally, if we wanted to print just the letters H to O, what we can do is we can type a print statement, again refer to that variable text, open up the brackets, and now we just need to say, don't just grab the first item, grab the first or 0th item H, all the way to the item index of O. So we just tested that, where the item index of O was 4. It's giving us an error here because I still have that open bracket, so I'll just comment that out so that Python doesn't read that line, and this is why we use comments. So when we're processing that, but we still want to check something, we may want to just comment that out. Now I can hit play to debug. We can see that that index is 4. So I'm going to open up the bracket and tell Python that I want the indexes 0, 2, specified with a colon, so 0, 2. We can start by just placing in a 4. Now if I hit play, we can see that on line 29, so that third print statement, it's just printing out HELL, not the full hello. So this might be confusing to you because we've printed out here index 4, which is the O, but then here on line 29, when we're referring to a slice of that string, we're only getting HELL. Now the reason why is you can think of this slice or this colon as referring to the words up until. So when I think of that, I try and think of maybe up to, but not including, right? So we're using the 0th index up to 4, not including 4, but up to 4. So it includes 0, 1, 2, and then 3. So 0, 1, 2, and 3 in this string are HELL. If we want to include the fifth index, or index 4, then what we want to do is make that to index 5. Now if we hit play, we have HELLO. This same logic is important to note, that because indexes start at 0, if we were to think about this entire string of length, whatever it is, its length, right? So in this case, 1, 2, 3, 4, 5, 6, including the space, 7, 8, 9, 10, 11, 12. So it's of length 12. If I actually just print out here, print text index 12, and I hit play, we're getting an error that says index out of range 12. That's because we only have indexes starting from 0 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, but we don't have an element or an item at index 12. So really when we're referring to indexes in any list or characters in a string, we need to be careful about referring to the length of the list minus 1 because that list is shifted, not starting at 1, but starting at 0. So this is something that will come up often when you're programming. So that index 12 does not work. Instead, what we can do here is refer to a function called length, and we can give it the length of our variable. So a list of characters, our string here. So length of text. And before we print that, I'm also going to just print out that length text. So when we hit play, we're already getting an error because it's just reading past that. So I'm going to comment out our line 31, hit play. On line 30, we're starting to see a lot of printouts here, so it's getting confusing. I'll comment them out shortly. But on line 30, we see first that it prints out hello world O, then it prints out HELLO, so our slice from 0 to 5, and then print length of text. So this is going to give us that value of 12, which we determined by counting is our length of this string. So now when we go to type print text and then open up that list and try to access its 12th index, it doesn't exist. So instead what we have to do is say length of text minus 1. Now we can hit play. So this is going to give us that last value there, that last character, which is an exclamation. So we see that printing out there in our console. Now, a kind of shorthand way of saying the same thing is instead of print text length minus 1, we can just say print text minus 1. Now, the minus 1 index means instead of starting from 0, going 0, 1, 2, 3, all the way to the length minus 1, we can just go backwards 1. So we can just say, take the last element, or like the kind of end after the last one, go minus 1, so that's the last element, or 0 minus 1 is the last element. So we're kind of thinking about it as a wrapped definition of this list. But it's really just shorthand for length minus 1 there. Now if we click play, we can see that 2 exclamation points are printed out because that minus 1 is referring to the last element in the list. So now I'm going to jump back into integers and we'll look at a couple of other operations inside of our integers. So integers are whole numbers, and we can see that by setting this value to 3, we're printing that variable value 3 below. Integers are useful for performing mathematical operations. So anytime we want to perform a mathematical operation in Python, we can just take that variable and then using math operators, we can perform the operation. So I'm going to start this by taking our variable num, making a new variable called result, and setting this equal to some operation on num. So we can start with num plus 1, and then print our new variable result. So not only can we store information inside of a variable, but we can also store the output of an operation, like num plus 1, so a mathematical operation here, and set that equal to our variable. So we're storing the output there inside of our variable. Just like we've done for all of the other variable types, we've taken some information and stored it, but this time we're actually running it in the same line and then storing the output into our variable. So now if we print this result, we can see that we get first 3, which is the num variable, and then we're adding 1 to it, so we're getting 4 there. We could also change this 1 to a 2, hit play again, and now we see 3 and 5 appear in our console. So that's 3 plus 2 equals 5. Our result is then equal to 5, and then we're printing that value of 5. Additionally, instead of addition, we can use a multiplication, which is signified with an asterisk. And if we hit play, we now have that 3 variable times 2, which equals 6. So we're printing 6 there. We could also do division. And when we click play, what we've now done with division is we've converted this integer, that number 3, we've divided it by 2, and now we've changed that to a variable type float because the result is 1.5. So we haven't actually changed the number variable. It stays as an integer at 3, but our result value, which was an integer, is now a float value. We can double check this just by clicking on this line here, and then we can go ahead and click play. So I've set that breakpoint. We actually have to go down to line 42 in order to actually run the print output. So once we've run that, setting the breakpoint there and then clicking to debug, we can see that we have name result with a value of 1.5. So that's the value stored in that variable. So a name of the variable is result. Our value is 1.5 and our type is now float. You can see just above that where we're printing our num, we have a name num, which is our variable name, a value 3, and a type integer. So we're changing that by dividing by 2 into a type float. Now I can go ahead and stop this debugging, hit OK, and now we see the printout back in our console. Additionally here, if we had two variables, so not just num, but if we said num1 equals 3 and num2 equals 4, and then I'm just going to comment out using control and / to select or highlight that line, and then apply that pound or hashtag to comment out those lines. And then I'm going to just select all of these lines above as well, and then hit control / just so that we can keep this clean. Now we have num1, num2, so two variables there, and we can use those in our mathematical operations by saying result is equal to num1 plus num2 and print the result. Now if we hit play to debug, so it's giving us an error here just because we have num being used later on. So what we can go ahead and do is just comment these lines out as well. So I'm going to just select each of these lines below and just comment them out so we can focus on our integer set. And now I'll click play. And we can see that we're printing out that result of 7, which is the value 3 plus the value 4 equals the result. And then we're printing that result. We can go ahead and jump down to our float section. And I'm going to just uncomment these lines by selecting them and hitting control / again. So that's going to uncomment those lines of code. And now we have our float variable set to 3.24, and then we're printing that variable out. If I click to debug, we can see that that 3.24 is now printing out in our console. And if I hit enter, we can perform the same mathematical operations on our floats. So this time I'm going to say result. So we're going to override that variable result and set this equal to num_f divided by num_f. Now if we print this result value, we can see that this prints a float value of that resulting value, which is 1.0. So it's not 1, it's not an integer value, but it's going to be 1.0. We can also nest some of these mathematical operations inside of parentheses, and we can perform, let's say, numf minus 1, and then divided by using that / numf. So now if we hit play, we get a result of 0.691358. Instead, we could use addition inside of this, hit play again, and we get the resultant value there as well. So any mathematical operation can be performed on integers or floats, and we can get the result kind of compounded from that operation, store it into a variable, and print it or use it later in our code. Now I'm going to jump over booleans because we'll return back to them when we get into conditionals, and I'm going to jump back into lists. So I'm going to highlight all of these, uncomment with control and then /, and then we right now have this line which is storing a list of all of our variables that we had declared. But when we hit play, we're getting an error, and that's because our num variable is no longer declared. So we could either declare this somewhere above the list, meaning write the name and set it equal to something, and then hit play, and then that totally fixes this. Or we could just go ahead and comment those lines out anyway. So now when we hit play, solved. Just like what we went through with the kind of list operations or index operations with the strings, those exact same things can be performed with lists. So with our list, right now we're just printing each item, so hello world ! And it's showing us that it's a list inside of brackets. We could also just print list index 0, and that's going to just print hello, no longer showing the quotes because it's printing the actual item hello, not the reference to the entire list. Alternatively, we could change this index value to 1 and print world, or 2 and print exclamation. As I mentioned previously with the string, we could also print, by just copying this here, index -1, and that's going to just give us the last index, which is also that exclamation. So in this case, -1 is the same as saying index 2, because they're both referring to that last index in this list. So again, very similar to the way that we were working with the strings, because strings are really just a list of characters. To operate on a list, as I just mentioned, since strings are lists of characters, really what we have here is a list of 3 different lists, right? So the first list being a list of characters, HELLO, and then the second being a list of characters, WORLD, and the third being a list of just one character, exclamation point. So what if we wanted to, let's say, refer here, just as we did, to indexes 0 up to the 5th index, which gives us the entire word hello. So we wanted to refer to that, but just in this first element, referring to hello. Or let's say instead of getting that entire word, we just wanted just that H. What we can do is we can open up the first list, printing list of that first item, right? So we want to open up that item that stores the value for the list of characters or string hello. So if we click play, that's going to give us hello. And now inside of that list, we want to open that box as well, right? So we've stored a box inside of a box. We've opened the first box and grabbed the first element with that index 0. Now we want to open another box. So we're going to open up another set of brackets, opening another box, and get the first item inside of that box with another index 0. So now when I click play, instead of printing out hello, it prints out just H. And as I move through each of the indexes, so 1, we get E, 2, we get L, and so on. If I change this first index, it changes which item we grab out of the first box, meaning we would go to that second index, index 1, and it's going to print R, which is the third item in that second item of the list. So this is what's called a nested list, where we're grabbing one item from the larger list, or the big box. We're then going inside of that box, and we're grabbing another item inside of that little box. The last operation we're going to go over for lists for now is adding 2 lists. So right now we have a list with 3 elements, hello, world, and then exclamation. What if we want to add to this? Well, any list operation we can access by typing the variable list and then hitting period. And this allows us to access certain methods, functions, properties present inside of this variable type. So with lists, we access this series of functions, the first being append, and then count, extend, index, insert, pop, remove, reverse, sort. So all of these are operations we can perform on our list. What we want to do right now to add is just use append, and then anytime we're using a function, which we'll come back to later on, we want to open parentheses, and then inside of these parentheses we want to place whatever we're adding. So we just want to add another string, and we're going to call this hello again. And then to close this out, we close the parentheses. As we do in basically everything in programming, we need to open something and we need to close it. We can't just leave it open. So now if underneath here we print the list again, what we're going to get is this hello again added as a 4th element to the list. So we now have element or item hello, item world, item exclamation point, and then item hello again. We could continue doing this however many times that we would need to. So we could keep appending and appending and appending to this list as needed. Now we're going to go ahead and get into conditionals. So conditionals are if-else statements that test for some true or false value, or a statement of equality, meaning is this thing really equal to this thing? And if it is, then perform an action. If it's not, or else, then perform a different action. And this is going to be our primary way of kind of segmenting or filtering certain portions of the code to only run under certain conditions. As I'm kind of saying this out, it's going to be written just like we would kind of use it in language. So we can start this by saying, if something is true, and these Boolean values are declared with capital T and capital F's. So if something is true, in order to construct this kind of zone that is filtered or only run under this condition, we need to give a colon to end this statement and then to enter into that filtered zone. So only if something is true, and then inside of here, we're going to say, then do something. So I'm writing this as a comment because this is not the proper syntax. But the idea is, if something is true, then do something. Alternatively, we could say, if something is not true, then do something else. Right? So that's the kind of language that we would be using. If something is not true, then do something else. Now, since this is not proper code in these comments, what I want to do is just give us a signal, which is going to be to print, and we can give ourselves a string, and we can just say that it is true. It is true, exclamation point, and then close out that string. Now, if something is not true, then we can say print it is not true, giving us information of whether or not it is true and whether it's running that print statement or whether it's running this second one, that it is not true. Now, our variable something does not exist right now, so in order to actually run these conditionals, we need to create that variable something and set it equal to either a true or false value. So to start with, we can set it to true and then hit play. And what we should expect is, since something is true, we should read this statement, if something is true, it is true. So then we should go inside of this zone, so inside of that tabbed space, and we should perform this action to print it is true. So when I hit play, we see it print it is true. Now what it's not doing is printing it is not true. And that's because it reads the statement, if something is not true, well, it is true. So that statement is false, so it doesn't run anything inside of here. That's why we're not seeing it print it is not true. If instead I make this something is false, then it's going to do the opposite. It's not going to run anything inside of this first conditional, and instead it's going to run everything inside of this second one. So if I hit play, we see it print out it is not true. That's because something is false. Instead of saying it is not true, we could also just say here, if something is false. Now if I hit play, something is in fact still false, so it's printing out it is not true still. Right, so we're still getting that same condition being met. So it is not true is the same thing as saying it is false. Instead of having to say if something is false and if something is true, we have a way of shortening this to just if something is true or else, right? So if any other condition beside it being true is met, which basically is only if it's false, right? So or else, which can just be shortened to else. So we have if something is true, print this. If it's false, which currently it is, then print this. So if I hit play, again, it's the same outcome. It's printing it is not true. And that's because that else can just be a short version of saying or else if something is false, right? So it's basically saying that same thing. Alternatively, we could give some additional conditions. So if something is true, we know that it's false, so it'll jump to that else and then it'll do anything inside of there. But what if we had something else as a variable and we set this equal to true? And what if we wanted a condition where if something was false, we wanted it to run whatever's inside of this else statement, unless something else is set to true, right? So if both were false, we want it to run this last one, but if something else is true, we want some other thing to be performed. This is what's called an else-if statement, and this is short for else if whatever your action is. Now we can't just write this like this, else if, because an else-if requires another condition, right? It's not if else, it's saying or else if this condition is met, which can be shortened down to elif. So elif something else is true, then print something else is true, exclamation point. So right now what's going to happen is it's going to read something which is false, so it's going to ignore this first part. It's then going to go to this second section and check, is something else true? Oh, well, we know it is true. Okay, then go ahead and print something else is true. And then we all automatically, as soon as the condition of this conditional set is fulfilled, it does not continue on. So it is not going to read whatever is contained inside of the else statement. So this is how we kind of layer these filters if we want to check for multiple conditions. So if something is false, it's going to ignore. If this is true, it's going to run it. So if I hit play, it's going to run something else is true. Well, what if we make something else also equal to false? So now this first condition is not met. This second condition is not met. So the only condition that's met is everything but those two, right? So, or else. So now if I hit play, it's going to say it is not true. We could even refer to these here as both are not true, right? Meaning that that else statement only runs when both are not true. So we're now getting this printout, both are not true. A similar structure, but just written in a slightly different way. Instead of using the language here, if something is true, we could also say if something equals true. What the double equal sign signals here is a test for equality. So it's not declaring something equal to true like we're doing here above in line 77 and 78. It's questioning whether it's equal. So the double equals is a question of equality. Is this equal to true? So we could replace all of these and say, instead of is, we could say equals, and then hit play. It's going to perform exactly the same. Alternatively, other tests for equality are going to be is not. So again, we could use the language. So if something is not true, we could also use this condition here, is not true. And in this case, if something is not true, that's actually correct. It is not true, it's false. So we're going to get it to print, it is true. But that's actually a bit misleading now, so we should say it is false, since we've changed that condition. So it is false. And since this one also is not, we can change that as well. It is false. Just so that our both of our conditions match, and then we can say here, both are true. Okay, so now if we hit play, something is not false, or rather, something is not true because it's false. So if I hit play, it's printing it is false. If we make that true, that condition is no longer met. If I hit play, it's now running this second condition. Well, it's not true, it's false, so it's printing something else is false. What if we make this true? Now when we hit play, both of these conditions are not met. The only one that's met is the else statement, so it's printing both are true. Instead of using these Boolean statements themselves, what we can do is we can actually use some mathematic value. So we can apply mathematical operations and test for number equality. So let's go ahead and start this with num1 equals 1, num2 equals 4. So to start this, the easiest way to test for equality is if num1 equals num2, print they are equal. So if we hit play, we are not seeing it print they are equal, and the reason why we're not seeing it print they are equal is because 1 does not equal 4, so we should expect this. Now, what if instead of a test for equality, we said if num1 is not equal, so a test for inequality, just like we're doing above. The kind of shorthand for this is an exclamation and an equal sign. So is symbolized with the exclamation and equal. Now if I hit play, they are equal is an incorrect statement. They are not equal, we should say again. As we change the conditionals, we should probably change the print statements. So they are not equal because num1, 1, is not equal to 4, which is num2. Alternatively, we could say if num1 is greater than num2. Well, num1 is not greater than num2, so we're not getting that print statement that they are not equal. So again, we can say it is greater. If we want to print out the alternate condition, meaning that in fact it is not greater, then we can say else print it is not greater. And now when we hit play, we see it print out that it is not greater. We could also say a check for if num1 is less than num2. Well, 1 is less than 4, so we're going to now get a printout of it is greater, which we see that printout in our console. So if num1 is less than num2. We can also, instead of just printing inside of these conditionals, actually place any operation inside of them. So let's say we want to perform a mathematical operation inside of these. We can say, okay, if num1 is less than num2, we want to make it bigger than num2. What's one way of making it bigger than num2? We can add num2 to num1. So we can say, if num1 is less than num2, print it is greater, and then add to num1. So we're going to replace the variable or the data stored inside of the variable num1. So num1 equals, what does it equal? It equals num1 plus num2. Now print not anymore. And in addition to our not anymore, we can type comma, and we can actually print multiple things inside of this print statement. So we can also print the new value for num1. So I'm going to print the value for num1 itself, also with the string not anymore. Now when I hit play, it's going to run the test. If num1 is less than num2, which it is, it then tells us it is greater, which we should say here it is not greater, I suppose. Again, we got to change these print statements to keep up with our conditionals. We could say now it is, because now it is greater. So now if we hit play again, we see that print out it is not greater at first. It then performs the mathematical operation, and then it says now it is, printing that string, and then printing the value, which is 5. 5 is in fact greater than 4, and that's because we're adding those two values. We can also nest conditionals. So if we wanted to do an additional check and say if num1 is greater than num2, then print that statement, just to be sure that it is in fact greater than num2. Now if we hit play, we can see that it still prints out that now it is 5. Right? We could also say now it is 5 with a colon there, print the number, and then comma, which is greater than, and then we can add the value for num2. So we're now going to say now it is 5, which is greater than, and then that number, which is 4. So if I hit play, now says now it is 5, which is greater than 4. So this is both great for passing information to ourselves, the kind of author and reader of this script, of this code, but it's also helpful for filtering information and only running certain operations at certain times or under certain conditions. Next, we have loops. So loops are going to be the way that we can iterate through multiple operations in a row. The base for loops is going to be the syntax for I in range, and then some number value. So the function here that we're running is range, and just like we did in Grasshopper, this is going to create a series of numbers from a certain minimum to a certain maximum. So we can say inside of here, 0 being the minimum, 4 being the maximum. So that's going to be a range of 0 to 4. So for I in range 0 to 4. And now inside of this loop, we can print I and then hit play. And that's going to print 0, 1, 2, and 3. It does not print 4 for the same reason that our string or our slice of our string did not extend all the way to include that 5th index. So anytime we're referring to a kind of cap or maximum, it goes up unto that point, but not including that index value, right? So 0 to 4, which only goes 0, 1, 2, and 3. Additionally, we could just shorten this to for I in range 4, and it defaults to a starting point of 0. And if we hit play, it now prints again 0, 1, 2, 3. This is like a shorthand way of saying 0, 4. If we hit play again, we can see again that's the same value. I'm going to just comment out all of these conditionals as well as some of these statements above here, just so that we get a little bit cleaner code so that not so much is printing in our console. So we still get 0, 1, 2, and 3. Within this range function, we can also declare a step, which is a kind of invisible third input here. So if I say 0, 4, 2, then we step through from 0 to 4 in steps or increments of 2. So if I hit play, we now get 0, skip 1, 2, skip 1. If we increase this maximum value to 12 and hit play, we go from 0 to 11, skipping every other 1. So 0, 2, 4, 6, 8, 10. If I make that step 1, we go from 0 to 11 all the way through. So 12 values there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I'm going to comment out this first loop, and then we can take a look at a few other conditions for loops. Since we can use loops to iterate through some operation multiple times, if I set a variable here, num equal to 0, and then I construct a for loop for I in range 4, and inside of this loop, every time we run this loop, instead of just printing out the value for I itself, we can say num equals I, print num. So now every time we run this, we're overriding num and printing that value. So this is basically the exact same thing as what we have above, which is just directly printing I. If we tab this print statement out and then hit play, it's only going to print that last value. And that's because every single time it iterates, it overrides the variable num And first it's set to 0, then it's set to 1, 2, 3. It exits this loop, or this for in range statement, and then finally it prints outside of the loop itself, so it just prints that last value for num. If instead of overriding that variable, we wanted to add some kind of mathematical operation inside of this loop, we can do that as well by setting num equal to itself plus I, and we can just check printing num and then printing the final value at the end. So if I hit play, we can see that every single time num for the first time is 0, that gets passed into our range where our I is 0. 0 plus 0 equals 0, and we're printing 0. Then I becomes 1. 1 plus 0 equals 1, so we're printing 1. Now I is going to be 2. Num is already 1, so 1 plus 2 equals 3, so we're printing that 3 value there. Now I is 3 and the num is 3, so now we're printing 6, and then finally we print an additional 6 at the end of that loop. Just like we can do this with a range of numbers, we could also do this with items in a list. So if we make a list that has an item hello, which is a string hello, and world, and exclamation. Oops, missing an equal sign here. So list equals hello, world, and exclamation. That list has 3 items inside of it, and in order to iterate through each one of these items, we can say for item, just declaring a variable here for item, so we can actually call that I whatever we want. It's just saving a variable. So for item in our list, so not a range of numbers, but a list. For item in list, print item. And now when we hit play, we get hello, world, and then exclamation all printed out separately. If we wanted both the index value and the list item, what we can do is what's called a list enumeration. So we can say for I, comma item in, and then we need to type in enumerate, and then put that list inside of parentheses. And now we can print I, comma item. This is going to print 0, 1, 2, and also be printing hello, world, exclamation point. So that's what's called a list enumeration, where we're iterating through each item and index at the same time for that list and unpacking them into 2 separate values there. This is one of the quickest and best ways of operating on a list, not only knowing its location relative to other data in the list, but also knowing the data itself and being able to operate on it. The last type of loop that we're going to go through in this introduction is going to be a while loop. So for a while loop, it's going to run until some condition is no longer met. So this is going to be a kind of combination between a loop and a conditional. The reason why it's slightly different than a standard conditional is because it runs a number of times, multiple times, until that condition is no longer met. So while that condition is true, it's going to continuously run. These can be very dangerous, and we need to ensure that it has a stopping point, otherwise it will just run forever. So if the condition is met forever, then your code is going to run forever, which can bog down or shut down your computer depending on what you're running it on. So in order to use these while statements, we first need some condition. We can say a variable number or num equals 0. And then we can say while num is less than 10. And now inside of here, we need the condition for which it stops. So in this case, we're going to just count the num up 1 every single time this loops. So num equals num plus 1, print num. So what's going to happen here is it's going to run until the num is no longer less than 10. and we can ensure that that eventually is going to happen because we're continuously adding to 0. So if we hit play, it's printing out. Since we're printing after the addition, it prints out 1, 2, 3, 4, 5, all the way to 10. If we did this print statement beforehand, we would see that print out from 0 to 9, because once it actually becomes the value 10, it's no longer fulfilling this condition. The while loop stops. Alternatively, if our number equaled, so our num variable equaled 20 from the start, and I hit play, it's never satisfied. So it never even starts running that while loop. So we don't actually see any of those outputs or any of this code that's present under this while loop or in that tab section doesn't run at all, because num being 20 is actually already bigger than 10. Now what we want to be careful of is now setting num equal to 20 and then making a condition for num to be greater than 10, which it is at the start now. And when we're running this, we have num plus 1, meaning that it would be 20 for the first run, then it would be 21 for the second, which is also bigger than 10, 22 for the third, and so on. So it would continue to increment in steps of 1, and it would go on forever because every single value of 20 plus an additional number that is positive is always going to be higher than 10. So it would just continue to run forever. So we want to make sure to say num is less than 10 and have a condition that eventually stops running. I'm going to comment these out, and then we're going to get into the last type of data structure. So these are going to be called functions, and functions are a packaged set of operations which we can call later or somewhere else in our code to run a particular set of those operations. So imagine we want to perform a loop, but maybe we want to perform that loop with different information being passed in several different times in the script. So functions are going to allow us to only write that operation one time, pass in a bunch of different types of information at different times, process that information in the exact same way because it's written the same way every single time we process it, and then pass out that information to wherever we're calling that function or using that function in the script. So these are going to be structured by saying def to define a function. So this is the definition for the function. And why it's called def is because this is it is where we define the function, but it's not actually where we run the function from. So when we declare def here, Python is actually going to read this information that will follow this def and be nested inside of it. But it's going to actually, when it sees that def, will skip it first, and then it's going to look for a place in your script that you're referring to this function, and it's only going to run the information inside of here when it sees that it's being used or called. So we can say def space, and then we'll make a function here, which you can call whatever you want, but we're going to make an addition function. Open and close parentheses. So a function is defined by def space, a name, and then an open and close parentheses, and then a colon and enter. Now everything inside of the function, all of the operations are going to be in this tabbed space, one tab inside of this function. This lets Python know to only run what's inside of this tabbed space if the function is being called. So inside of this function, we can say print num, and then we need a variable num, which we can set equal to 0. So we have that variable num equal to 0, a function, addition function, so it's called addition function. Right now we don't have addition being performed, we're just printing that num. So if we click play, what's actually happening is nothing. So not only is it not printing that num, but it's not actually doing anything. It's just reading, it's declaring a variable num, calling it num, storing 0, and then it's reading the definition for this function, but it's not actually running the definition, or it's not actually running the function. So it's not actually running anything inside of the function. And that's because we actually have to call the function in order to run it. So it's going to be called with just referring to its name, just like a variable, but we need to open and close the parentheses. This is similar to what we did with the append function for a list. So really, any of these things like enumerate is a function, which we're opening and closing a list with. Range is a function, which we're opening and closing with those parentheses. Append is a function, and that's why we're using those parentheses. What else is a function? Not here, because that's a mathematical operation that we're using parentheses. Length, or len, is also a function, and that's why we're opening and closing them with parentheses. So really what's happening in those other places is that the function is defined somewhere else, like it is here in some of these Rhino script syntax locations. So those functions or methods are defined somewhere else, and we're just calling them in our script. So that's how all of this kind of coding structure is working. So here we're creating a custom function called addition function. Now we're calling it, and we're signaling that we're calling it with the open and close parentheses. And now when we click play, we can print that number, right? So we're printing that num variable. So we're printing that on line 136. And if we set a breakpoint here and click to debug, we can see how this is stepping through. So it says num, so variable name num, with a value of 0, and it's an integer type. And then just below it, it says addition function. So that's the name of the function. It's a value of a function, addition function, in the main script, and it's of type function. So it's reading that function. So we can see that Python is actually reading this function. And if we stop that debugging, hit OK, now we can start to nest operations inside of this. So to make this more useful, instead of just printing num, we can keep that print statement. I'm going to hit enter at the beginning of that line, so we're still in this tabbed space. And now I'm going to say num equals num plus 1, and then hit play. So what we're getting here is an error saying the local variable num is referenced before its assignment. And the reason why we're getting that error is because we actually need to pass information into a function when we use a function. So we haven't actually given any of this information to the function. You can think of this definition and tab space as a kind of barrier to the outside world, meaning this num, that variable is defined outside of the function, so the function has no idea what's happening outside of its function world. So in order to pass this information into the function, we have to feed it inside of this set of parentheses. So we're opening the function with this parentheses set, and to give it this information, we put that information inside of the parentheses to feed it to the function. Now if we hit play again and debug, it's giving us a different error, which is saying that the addition function takes no arguments, and we gave it one. This is because inside of these parentheses, where we define the function, we don't have it reading any variables. So here we need to give another name for a variable, which we could either name num. So we could name this num and then hit play, and it's going to read that num that we passed in, read it in here where we define the function, and then it passes that information all the way to all of these variables that are occurring inside of the function. And then we can see that print. So I can hit play, and we can see it printing 1. This is, you can do this, but it's not, proper syntax. I think the better way of doing this is to give some reference that this is the num inside of the function. So one way that you can do that is by giving an underscore in front of that variable. So now we can say underscore num equals underscore num plus 1, print underscore num. And if we hit play, we're going to get that 1 printed out. Now, the reason why this is important is because we're no longer referring to that data within the variable num. We're passing it the variable, We're then replacing that variable. So we're saying, let's make a new variable called underscore num. Let's take the data from num and put all that data in the container called underscore num. And now when we're inside that function, we're just going to use the variable underscore num to signal that it's the variable inside of the function. If we wanted to pass this information, underscore num, outside, so outside of this function, we can use what's called a return. And we can say return underscore num. When we do this, we can then print anything that is returned. So now when I hit play, we're going to print that one value which was returned from the function. Alternatively, we can say result equals, and then we can say print result and play. And this prints that result which we output from the function. If we wanted to perform this operation twice, we could just go ahead and copy this line 138, calling this function twice, not having to rewrite the entire data structure, but just writing it and defining the function once and calling it twice. And instead of feeding in the num, I want to feed in the result, and we're going to just print first round, comma result, and then we'll print second round, comma result, and we'll take a look at what this prints. So when I hit play, we get first round 1, second round 2. That's because we're running this function, getting an output of the number which was 0 plus 1, which gives us a value of 1. That's being passed down here on line 136. It's returned as an output, so result is set as the number 1. We're printing that number 1 right there. We're then using that number 1 stored inside of the variable result, passing it back into the same function. So this underscore num now equals 1 and not 0. Well, 1 plus 1 equals 2. And then we're returning that value of 2. So result equals 2. If we didn't want to constantly call this, but we still wanted to kind of loop through these operations, one way that we could do this is nest the call for the function inside of a loop. So combining some of these data structures, we can nest this call inside of a loop, calling it however many times the loop runs. So I'm going to go ahead and copy all of this and then comment it out using control and / and then paste this down here, and we can delete that second call of that function and the print statement. Okay, so instead of running it one time, I'm going to say for I in range 4. So we're going to run that 4 times from 0 to 3. And now each time we run this, instead of outputting result here, we're going to say num equals addition function, pass in num. And then we can print num each time we run this. And if we hit play, we get 1, 2, 3, 4. That's because the number 0 is being passed in here, running the function. So it's saying whatever that variable is, let's override it with the output from this function. Let's pass in 0, run this function one time. That's going to give us a value of 1. So we store that there and print 1. Well, now in the second loop, we're going to say, okay, our num is 1, so we're passing in 1 plus 1 equals 2. Okay, so print 2, and then 3, and then 4. If we add an 8 instead of 4 to this loop and hit play, we now iterate from 1 to 8. So iterating through in the loop 0 to 7, but our number is 1 to 8 there, because we're actually adding 1 every time inside of our function. Instead of adding 1, we could also multiply by 2 each time, hit play. Since our starting value is 0, we're just getting 0. If we change the starting value to 1 and hit play, we now get 2, 4, 8, 16, 32, 64, 128, 256. We could alternatively say num times itself equals itself. So we're overriding that variable with the square of itself. When we hit play, since it's 1, it's just going to be 1 repeated, those 8 times. If we make this 2, then we get the square of 2 8 different times, which you can see quickly gets to be an incredibly large number. Alternatively, instead of multiplying it by itself, we can also just feed in multiple data values. So we can say num1 equals 2, num2 equals 3. And then here when we're looping through, we'll start actually by taking this out of the loop, hitting Shift-Tab to untab, and then just deleting that loop. And then here where we call our function, we're going to pass in num1. Then we're also going to pass in num2, separated by a comma. So if we hit play, this is going to say takes exactly 1 argument, but 2 are given. So this is just like when we were passing in 1 data or 1 variable, and it didn't have any defined in the function. Now we just have 1 defined. So we just need to say this is num1, and then underscore num2. And now if we hit play, it's giving us an error because we don't have that num1. So we can say result equals, and we'll make this underscore result, and we'll return our underscore result equals num1 times num2. And then we're going to make this result and print result. So what's going to happen is we read num1, num2, pass both of those data points in, so 2 and 3. We read them in here, 2 and 3. Our result then equals 2 times 3. So 2 times 3 equals 6. So then we should return a result of 6. So this should print 6, which it does. Now if we make an addition, it should print 5, which it does. And just like we did with the for loop on the single input, we can do this same thing, but nested inside of a loop. And we can say for I in range 10, result equals, and here we might want both results. So let's say result 1, result 2, to unpack each one of those values. Right now we're just returning 1 result. So here we'll also say, this is num1 and num2. And instead of using result, we can just use num1. So num1 is going to increment using addition, and num2 is just going to remain the same. And now if we tab that in and print result 1 and result 2, we'll get each of those results printed out each time this loop runs, which is 10 times from 0 to 9. So if I hit play here, for in range, it's meant to be for I in range. So just a spelling error there. So it's now printing 5, 3, 5, 3, 5, 3. That looks, this makes sense. This is because we're just outputting the results, but we're not actually feeding these results back in as the number values. So what we need to do is overwrite, instead of outputting as results, we need to overwrite num1 and overwrite num2 as those return values, and then we can print num1 and num2. And now what we should see here is num1 is iterating through addition, and num2 just remains the same at 3, which we do see. So first it's 2 plus 3 equals 5, so num1 equals 5, and num2 equals 3, and then it's 5 plus 3 is 8, so we're seeing that 8. 8 plus 3 is 11, 14, 17, 20, so it's just incrementing in steps of 3, and then num2 stays at 3. So that's all for the introduction to Python data types and data structures inside of Python script. We're going to be getting into a couple of project or exercise-based introductions to Rhino script and how to construct geometries, but also other ways of thinking through not just the variable types or general data structures, but how to use conditionals and really think through them or apply them in a way that makes sense inside of Rhino in the next few videos.